Thanks everyone for coming. Welcome. So essentially, we're going to go over a tool based called RosettaDB. Presenting is Nui. Nui is a chief data scientist and entrepreneur. He has great experience with managing teams and technologies and business operations. It's in addition to his academic work that he does in data science and big data. He's worked with quite a bit of large U.S. companies supporting very large big data operations, which number in like thousands and thousands of nodes. He's on quite a bit of academic boards and commercial entities for advisory positions. So he'll be presenting for us today. So thanks, Nui, for your time. Please go ahead.
Thank you, Byron. Thank you for a great report. So I'll prepare now and I'll start presenting the topic on today's webinar. So first, let me share my screen and we'll get started. So I hope you can see the screen, right?
Yes.
Great. So as Byron said, I'm Louis Bassimi, and today I'm going to be your presenter on the topic database migration with RosettaDB. RosettaDB is a tool that is going to play the main role today, and that is an open source tool that we have built, and now we are going to present the following agenda that related to RosettaDB. We'll start a few words with an introduction. Then we'll discuss the challenges that enterprise companies today has with the database migration and how we ended up with these challenges and why these are so important. Then we will introduce the Rosetta and how RosettaDB actually can help us solve all the challenges presented above. The second part will be mainly demo, and it will be showing all the features, functionalities of RosettaDB and some real examples with real data and how we can benefit of it. And the final part of our webinar will leave some time for questions and answers and some tips on how everyone can contribute and how you can become part of this RosettaDB and how you can become part of this open source project. I don't have much to say about myself because Byram already introduced me. So we'll continue with the main problem that we are trying to solve with RosettaDB. Our team has been working a lot with enterprise companies around the world, and we have been helping lots of data engineers and companies migrating their data and their solution to cloud. Besides that, they have had lots of requirements like we want to move to cloud, we want to move our databases to cloud, or we want to build our data warehouses to cloud for various data analysis, data visualization, and so on. As a result of that, we have been having lots of issues and challenges doing that process. Sometimes migrating to cloud may sound a very easy task, but when you have to deal with a single table. So take into consideration that there are big companies there that have different data types, they have lots of databases and lots of tables and tables with, I don't know, sometimes with hundreds of columns. The process of migration can become really challenging and sometimes an unsolved problem. So what are the main challenges with database migration? Usually data engineers, they end up doing lots of manual work by converting DDL and DML scripts and writing a lot of SQLs to convert from one source target to a cloud database, for instance. And it requires lots of manual work, checking the schemas, extracting one DDL, and so on. In fact, there are tools today, as we can see, that can help us in some way solve all these challenges, but none of these tools like Flyway, Liquidbase, DBT, or Switch, or whatever, does not provide you an end-to-end solution that is going to help you with this process of database migration. Regardless what you were using and what approach you were following, again, at the end of the day, you are ending up creating your own scripts, managing your scripts, and then dealing with different environments and so on. So one of the main reasons, one of the goals in our team was how we can simplify this process and how we can make this easy configurable and easy to use. So as a result of that, we created RosettaDB. RosettaDB, the most important thing is an open source tool that we can also say that RosettaDB is a declarative database modeler that allows us to handle our database models by using a declarative database modeling language. And we'll discuss more later about that, and we'll see how that looks like. RosettaDB allows you to do a DDL transpiler. It gives you the ability to convert from one schema from one database DDL to a target database DDL, much simpler. On the other hand, RosettaDB allows you to generate DBT models. DBT is another data-related tool which enables data analysts and engineers to transform their data. So the DBT focuses mainly on transformation to make the transformation of data in warehouses much more effectively. RosettaDB allows to do a database testing toolkit. Since the quality of data is very important with RosettaDB, you can also check the quality of your data and run various tests on your data actually that you have migrated. It gives you a great tool. It's a great functionalities for design methodology, and its architecture offers you like translation, extraction, transpiler, compiler, executor, state management, and a test framework all in a same open source tool. I said lots of things related to what Rosetta is, but we'll have a chance in the demo to see all these things together with a real use case. What does declarative data modeling mean? So we as one of the first feature functionalities about Rosetta was it is a declarative database modeler. So Rosetta as a declarative database modeler uses a declarative database modeling language, DBML, which is based on YAML, and it allows data engineers to define their models as a text. This gives you some extra value because it allows you to treat your database as a code. And on the other hand, this is our main functionality, which enables to us to be able to do data structure translation from one source to another source. And how that DBML and how that YAML format looks like, we already have that in this slide. So here we see an example of a simple table named user, which has an ID, a username. We see only 2 columns there, but in the similar format with a single YAML file, we can represent the whole schema of a base, regardless number of the tables and columns that we have inside. So this is one of the main functionalities, core functionalities that RosettaDB is offering, and it enables the declarative database modeling by using YAML, and it allows you to treat your database as code. At the moment, Rosetta does convert schema from one database to another. It acts as a DDL transpiler for you. The supported databases are BigQuery, Snowflake, MySQL, and Postgres. The reason why these are the first 4 supported databases are that our team had a lot of experiences and was involved in different projects working and migrating, helping clients to migrate to BigQuery or migrate to build their data warehouses to Snowflake. And seeing that MySQL and Postgres was like very popular and widely used, those were the first databases that were supported. And actually that you can use Rosetta to do DDL transpiler and convert from one schema to another. For this, we'll see an example. And also by the end of this webinar, we'll have the chance to discuss on how we can extend this more and whether RosettaDB is extensible and what we need to know in order to do that. I already said a few words there. RosettaDB is also a DBT model generator. So DBT is another tool not built by us. It's a very famous, popular tool today. It's data build tool. It's also a command line tool that enables data analysts and engineers to transform data in their warehouses more effectively. In Rosetta, we have integrated the support for this DPT because today there are more than 800 companies that are using DPT in production, and being able to interleave together with it is going to be an added value for data engineers. Another functionality of Rosetta is that it allows data engineers to easily be able to detect any data anomalies by writing automatic tests. And these automatic tests, we can see from the slide down here that they are assertion-based tests, and you can write as many tests as you want, specific columns on various data values, and then be able to run that just to confirm the quality of your data, to detect errors, to detect anomalies, to verify whether your ETL jobs has run correctly, and so on. So how can Rosetta help? One thing that Rosetta is going to help companies is it accelerates the data ops so that you can treat your database objects as code defined in YAML files, in DBML, the files that we already saw, and makes your database management declarative. RosettaDB will allow you to do the table extraction much easily. It will allow you to do error detection, not only at the level of the data, but also to check the various schema changes and maintain the state of your database. And if there is a change, you want to apply a new change, you can do that freely with Rosetta. And it also allows you that all the artifacts that are generated from Rosetta can be version managed in Git, and then you can support CI/CD pipeline for data ops operations. And this gives you the ability to manage your database in a fully automated way using a Git workflow. So these are some benefits that we can see from Rosetta and how Rosetta can help today data engineers and companies. I think I talked enough related theoretical and just words related to the Rosetta. Let's get into a demo and see some real value, some real examples on all the functionalities that we presented here. So I'll go ahead and I'll start with a Rosetta demo. Just quickly, I'm going to show you where Rosetta is located, so everyone can find Rosetta under GitHub, under adaptive scale with the name Rosetta. And here you have all the details needed in order to set up yourself and get started with various functionalities that the Rosetta is offering. Every command, every functionality that is available, you can freely use it here directly and just reference it here and start using, configure it, and continue from there. So for our demo today, we have prepared some databases. I already have a MySQL database in my machine that is actually running on Docker. I have one Postgres database. In my MySQL database, I have one Sakila database where I actually have tables. We have a BigQuery already there, and we have one Snowflake. The use case that I'm going to demo is going to be migrating our Sakila database that is located in MySQL right now to BigQuery. So going from our Docker container from this database that I have locally to BigQuery, and moving all the tables that we have here, there, and demonstrating all the commands and capabilities of Rosetta. To get started with Rosetta, you need to download it and start by creating a project on your machine. To create a new project of Rosetta, all you have to do is use Rosetta init and type the project name. So I'm going to use for today demo, because we are demoing as part of this webinar, and I'll just type Rosetta init demo, and this should create a new directory for me named demo. And inside that directory, I should have now a new file called main.conf, where I'm going to specify the main configuration. And let's open this main configuration and tell you exactly what is it and why we need it and how it can help us to move forward and use all other features of Rosetta. So in order to make this much simpler for everyone, I'll open Visual Studio Code, and I'll open this new folder that I just created. And there we'll be able to easily see all the new files created, every change that we are going to do, and we'll run all the commands directly from there. So I'm opening that, and I'll show that immediately right now in the screen. Rosetta Demo, the project was demo. And here it is. So I just opened here in Visual Studio Code the demo directory that got created as a result of Rosetta init command. And as you can see inside this demo directory, at the moment, we have only one file, and that file is a main.conf. This is an example configuration, and in main.conf, we need to specify the connections. Main.conf, in a YAML format, we have to specify all the connections that we need. In our case, we are going to specify the connection for our MySQL, for Postgres, for Snowflake, and for BigQuery. So as soon as we set up the connections, then we should be able to get started with schema extraction and all other functionalities. I'm not going to go one by one to configure here. I already have them set up, so I'll just add everything here. So, and then we'll describe what every section means. I'll replace completely this file with a new content. So we have connections. I have set up here 4 different connections. The first connection that we have is MySQL. We have specified the database name. We have specified that this is a DB type. We have the JDBC URL. And you will notice one thing here. Here we have the list of tables that we are interested to continue and do some additional extraction or capabilities that Rosetta is offering with this MySQL schema. Since our goal in this use case is to migrate from MySQL to BigQuery, apologize, that's the reason why the list of tables that we are interested are already listed here. The second connection that we have here is BigQuery. The name of it is BQ. The data set name is the following. This is a project, and here we don't need a username and password because we are using the service account key, and this is in a JSON format located already in our machine. We have a Postgres. This is also running in Docker. The configuration is here. We have a Snowflake. I have intentionally not written the password here because we are not going to do any migration in Snowflake, but we'll just use Snowflake to do the DBL transpiler, to generate the DBT models, and to do the conversion. And it's enough just to have it now as a new connection. And if we want to apply and do the real migration, then we must specify the password here and to be able to run it and move everything from there. So as soon as we are ready, I'll open the terminal here now, just to make this process simpler. We'll see every file that Rosetta is going to generate directly here. We'll continue with the first thing. That is, the first functionality was that Rosetta allows us to do a table extraction, allows us to extract a DBML from our databases that we have here. The first command is Rosetta extract. We need to specify the source, from where we want to extract. In our case, we are going to extract from MySQL, and this can be enough for us to go to connect to this MySQL connection, to the Sakila database there, with this username, with this password, and extract in DBML format, in YAML format, all the tables that are listed in the main.conf. This is simple extract, and the goal is just to see the YAML files, the schema of this MySQL that we have here. Cannot find source with name MySQL. Okay, sorry, I didn't save it. Now it's saved. So we go Rosetta extract MySQL, and as soon as this command finishes, we'll notice that a new directory got created under our demo project. The directory name is the name of the connection, and inside this MySQL we have the model. So this is that DBML that we presented on during our presentation in the slides, and here we have the list of all the tables that we have listed here in main.conf. And we have, for each table, we have the columns and some additional attributes for every column, starting like column name, type name, and some other details. This is the first. Here we continue with the second table, which is the name, category, and so on. This is pretty straightforward. It just extracts the schema in a DBML format. But what if we want to convert this and be able to convert this schema, this DBML, to a target database source? For instance, we said that we want to migrate to BigQuery in our case. To continue with that, the second command, which is the following. Rosetta extract from source MySQL. So extract the schema from my source, and our target database is BigQuery. And as you can see, MySQL comes from the name of the connection, and BQ comes from the name of the connection, the second connection that we have here, BigQuery. We are ready with this command. We hit enter. It takes a couple of seconds, and now instead of two, we have instead of one, we have two directories. We have the model, which we already extracted from MySQL, but we also have a BigQuery DBML model.yaml, and this is the BigQuery model.yaml. They may look similar, but I'll just do a quick comparison on both of them. So this is the MySQL. On the right side of my screen, I have the MySQL model.yaml. On the left side, I have my BigQuery. So our source database was MySQL. And as you can see, the name of the actor, the name of the table here is actor. We have actor ID of type integer, same is in BigQuery. The first name in MySQL got converted to a first name in BigQuery, but instead of using text, BigQuery wants it as a string. This is the data type there. The last name in MySQL is varchar. On the other hand, it's also converted to string because we don't have text and varchar similarly in BigQuery. So it just converts every data type to the target database. And they are pretty similar, but we'll see the conversion, they are similar in the structure, but the conversion did adjust the data types and all other attributes that will help us to be able to migrate this model to BigQuery and build it in BigQuery. So the next command that we are going to demonstrate is actually Rosetta, the compile command. The compile command will help us to extract a DDL for the target database, and also the compile command will extract for us the DBT models, and it generate for us the DBT models just to make them available for future transformations that we are planning to do with our schema. So I continue with Rosetta compile. Again, we want to compile from source, which is MySQL. We want to go to target, which is BigQuery, and we just hit enter. As a result of this, we will see now that in the BigQuery directory, we, instead of model.yaml, we also have some new files. We have ddl.sql. ddl.sql is a DDL script that got generated, and a script that can help us simply just copy, review it, and go to BigQuery and create the tables that already were in MySQL and simply just migrate them there. But there is no need to do that. At the moment, this is only just for our, to review our for it to review. Actually, nothing has happened in BigQuery yet. Besides the DDL.SQL, we also have a DBT directory here generated, and we'll get back to this by the end of the demo. Well, we demonstrate what actually this means and how we can import these DBT models in a DBT project that we have already prepared for this demo. So we'll get back to the DBT directory, but DDL at the moment is what is about to create in BigQuery if we want to apply these changes that we generated from MySQL to BigQuery. As soon as we review this file, we are happy with it, we like it, and we want to apply these changes to a BigQuery, to our target database, we can simply just go ahead and run the following. Rosetta apply BigQuery. So there's no need to specify now a source and target. We already have the target. We have the model for target. We have converted it. All we have to do is now just tell to Rosetta what we need to apply and which model we want to have to migrate to our target data, to our database. And in our case now, the Rosetta apply command is going to take this model and build a DDL script for us, similarly like this one, and actually apply and do the changes in BigQuery and create these tables for us. Let me go ahead and check. Let me see the configuration. So here we have a Rosetta Demo schema name. I'll open quickly dbeaver. Let me navigate to my BigQuery account. We have a Rosetta Demo here. There are no tables. Let me refresh. Okay, so there at the moment we have Rosetta Demo, but there are no tables. I'll hit apply. And this command probably will take a couple of seconds, depending on the number of tables and number of columns. It looks like it's running. A new directory got generated. Meanwhile, I'll go here and just refresh this. Yep. In dbeaver, we already see the new tables. The command is still running, probably until it finishes with all the tables and all its columns. Yep, it's done. So it successfully written the DDL. We have a new DDL here under apply with a timestamp that got executed in BigQuery. We'll get back to the apply command again, but apply command is something that also checks if something already exists in BigQuery, if any of these tables with any of these schema already exist. And it does not always go and just create always from scratch all these tables. But if something exists, it also is capable of applying only the changes. But since in our BigQuery data set, at our initial phase, we had nothing there, no tables at all. It went ahead and created everything based on the model.yaml for the BigQuery that we have specified and we have converted from MySQL. If I go now to this BigQuery, let me just click few of the tables here randomly. We have now an actor table. Okay, is there film text, for instance? Okay, is there 3 columns, and great. One thing to note is that RosettaDB is not an ETL tool. RosettaDB is not going to move data. It actually is going to help you migrate your schema from MySQL to cloud, because there are lots of tools available today to migrate your data. If you want to move some data there, we have prepared a small script that is going to help us just move all these data for these tables we have extracted in CSV format, and with the help of a small script in Python, we'll just move a couple of rows in all of those tables. It should be real quick. Okay, those tables are getting populated, and it's done. So let me see what we have now in our BigQuery database. Refresh this. Do I have any data? Yep, I have data now in film text. Do we have anything in actor? Let me refresh it. Okay, we have data. We should have data on other tables as well. I'm not going to click around every table, but these tables are now populated. So the process of going from MySQL and moving and migrating to cloud was pretty straightforward. And all we had to do is just extract the model from MySQL, convert it to a model for BigQuery, and then just apply those changes directly to BigQuery. Another thing that we are going to demonstrate now is that Rosetta also helps data engineers to maintain the state and check for errors, check the difference of the schema of their database, data warehouse, regardless where it is. So I'll go ahead and do Rosetta extract BigQuery. Now we already have everything configured here. We have the schema in BigQuery, we created it, we saw it. The thing that we are going to demonstrate next is, let's get the current schema, DBML from BigQuery. This should be a bit quicker. Okay, it's done. Okay, model.yaml is here. Rosetta also has a functionality called RosettaDB, which does a comparison of the model.yaml that we have here with the current schema that actually exists in BigQuery. So I'll just go ahead, initially run a RosettaDB and source BigQuery. This will take this model and it will compare with the current schema that we have in a BigQuery. Our expectation as a result of this command is that this difference should show nothing because there are no changes, and it's something that we just created right now. But as a tool, it will, as a functionality, it allows data engineers to check over time if something changes on their data warehouses, if a table drops accidentally, if something new got created there, and if they want to reapply the changes, or if they want to add new tables directly from Rosetta. So how that can be done? Let's simulate some changes. So instead of me going to BigQuery, I'll just go ahead and update this model, because the first RosettaDB command just showed me there are no changes. I'll scroll to the bottom. And down here, I'll just select the last table. So I'll do two changes. I'll select this last table, I'll copy it, and I'll add a new table. And instead of store, I'll name this store TMP. This is like a new table in my model.yaml, but actually is not in BigQuery. Another thing that I'll do, I'll take this in store table, I'll just completely remove, I don't need the address, for instance. I'll go ahead and remove the address. So I'm for sure now that this model is not identical with the previous state that we had. So we'll go ahead and run again RosettaDB, compare it with the source, in our case BigQuery, compare it with the real schema in the BigQuery. This takes a couple of seconds because it needs to check all the tables, all the columns, and also checks the column types and other attributes related with columns. If there is a change in the scale precision, or if there is a change in the primary key, in the auto increment, or the field got changed from nullable to non-nullable and so on, then you can simply see all those differences with the help of this command. Now my expectation is to see changes. One table. So yeah, it says that table changed, table store, columns changed, column address ID got added, which means that someone in our database added address ID. We remove it from here, but the check is from the perspective if someone does any change in the database directly. And the table removed store TMP. I have store TMP here, and I expect to have it there, but someone probably removed it unintentionally or for any reason. So if we want to apply these changes that we have now in this model.yaml, we can simply just go ahead and run again Rosetta apply. Rosetta apply, in this case, compared to the first run that we did, will do only the changes, and it is not going to recreate all the tables from scratch, because it knows exactly what already exists in that data set and what are the changes that it needs to apply. After this Rosetta apply command is finished, we will also be able to see what script in background did Rosetta run in order to achieve this state. So it should finish in a couple of seconds. It's done. It found 2 changes. And it successfully written the DDL that it successfully executed. So first, let's see the DDL, and then we'll go and see whether those changes that we did in the model.yaml actually happened in BigQuery as well. So if I go under apply, here we can see that DDL, it did alter table. It has dropped the column address ID because we removed it, and it created a new table store TMP with the same schema as stored, something that we just copied and pasted directly in the model. Let me go quickly to the dbeaver. I'll refresh here to see first if store.tmp is there. Rosetta Demo, tables. Yep, store.tmp is there. It has 4 columns, but on the other hand, store table does have only 3 columns. So that is as expected, and it looks like Rosetta did the job and also applied the changes that were required based on the DBML model that we have in our machine. Another functionality that we wanted to demonstrate as soon as we have some data here now is that to test the quality of the data. So Rosetta allows you to write assertion-based tests and be able to run tests for the data. The test that I'm going to demonstrate, let me write just 2 or 3 tests only in this actor table. The tests are written in the model also, model.yaml. I'll go at the top. Here we have actor table, and we can write tests for any column that we are interested in. Now I'm interested to write tests for the actor ID. So I'll write tests, assertion, the operator that I'm going to use is going to be equal. I'm interested to see whether a value 16, let me see, database, do we have ID 16? Yeah, we have ID 16, Frantis with an ID 16. A value 16, we expect to have only 1 case. This is the meaning of this test is the following. We are testing the actor ID equals to 16. And in total, we have only 1 count with such occurrence. I'll go in the first name, and here let's test something with the names. For instance, I'll go ahead and write tests, assertion, the operator equal. Here we'll check for a specific value. I'll go to the data to see what we are interested in. For instance, let's check Nick. I'm interested for Nick. And we may have multiple Nicks, multiple rows with a value Nick for the first name. And I'll just write here expected 5, for instance. We will run the test and we'll then see actually how many Nicks we have in total. If you want to add more tests, you can simply add. I'll go ahead and check for the Rosetta DB. I can write something like this. And I expect to have 0 rows where the first name is equal to Rosetta DB. As soon as you are ready with all your tests, you can have as many tests as you want. You can have multiple tests per single column. You can have no tests per column, and you can go to any table based on your schema. And this is a great functionality to test the quality of your data, to test be as a post-processing after your ETL pipelines have finished for populating the data in your data warehouse and so on. So I'll go ahead. And the tests in Rosetta are run with a test command. I write Rosetta test, and the source that I want to test is BigQuery because I already wrote all the tests in my BigQuery model.yaml. I click enter. The tests are running. It found three tests we wrote. It's running. The first test passed. It was expected to pass because we saw that there is an actor ID with a value 16. The second test failed. It's okay. I was expecting 5 rows with value for first name Nick, but actually there are 3. And I was expecting 0 rows with value RosettaDB for first name, but actually there are 0. And all these 3 tests make sense. So this is the output of the test, and you can test anything related to your data. So there was one more thing that I wanted to show, and I told you that during the compile command of RosettaDB, it also generates the DBT models. In order to validate those DBT models and to integrate them in a real DBT project, let me just go ahead and run once more Rosetta extract from source MySQL, but in this case, I'm not going to, in this time, I'm going to change my target. Instead of BigQuery, I'll change it to Snowflake. And as a result of that, you will see that we have one more directory here, which is Snowflake, and we have a new model.yaml, new DBML for the Snowflake, and this is already converted to a Snowflake. As a result of this, all the schema now, the DBML is converted and adapted from MySQL. I'll run one more command, which is Rosetta compile source MySQL and target to be Snowflake. The DBT models got generated. I'll bring here in the screen a new Visual Studio Code project where this actually is a DBT project now. And in this project, I'll just do one thing. This project is already set up with a connection to Snowflake and everything. All I'll do is I'll copy only the DBT models, this directory and this file. I'm copying these two, and I'm moving them under this models directory, which is empty here in DBT. In order to validate now this DBT model that we imported from Rosetta, we can run dbt compile. Dbt compile will check if everything is okay, if it compile, and we are simply going just to generate the documents of this model, ask dbt to do that for us, and run that and see how everything looks like and how the schema looks like, just to make sure that everything is working. So no issues. It found 14 models. That was expected. Everything is done. I'll do dbt docs generate, just to generate the HTML files for document for this. This is one of the functionalities that dbt is offering, but its main functionality, its main purpose is for data transformation. And I'll go dbt docs serve, and let me serve under some port, for instance, 999. Quickly, we'll just see what is going to be. Okay. I need, for port, I need -- on command. And it just opened my browser. This is how it looks like. So we have the Rosetta test. We have all these tables from MySQL. We have the DBT models and so on. So that's it related to demo, since we have a few more minutes left, I'll get back to this slide deck. And ask everybody who is interested to contribute to Rosetta. The GitHub link is given here. For Rosetta, we also have an open Slack channel where you can get in, give your opinions, ask questions. If you encounter any issue, any challenge, you found a use case that you cannot apply and so on, please feel free to contact us. And related to how to make it better, there we have some plans for future related to Rosetta. We need more translators at the moment. You already saw that we were able to convert from MySQL to Postgre to BigQuery to Snowflake and all other combinations, but there are other data types that we need to support. And at the moment we are only supporting basic test types, but there is a possibility for extending that part as well. Since the project is all open source, everyone is open to contribute and share their ideas. Questions? Discussions?
Yeah, we have a few questions. First one is, how many databases does Rosetta support currently?
Actually, it only supports the 4 databases that I already mentioned: MySQL, PostgreSQL, BigQuery, and Snowflake. But for future, we are planning to support more. And in order to support more databases, it's like more, it's a configuration-based extensible. We need to write some JSON files where we write all the mapping for converting the data types from MySQL to a target database, which is BigQuery. And then this way we can add more translators. And we are more than happy to add more translators based on people's needs.
Awesome. Another question, what language is Rosetta written in?
Oh, I forgot to mention that. So Rosetta is written in Java, primarily because we wanted to leverage the JDBC. And another reason is that Java can be run in any platform. And I demonstrated from my Mac OS today. We can run in your Linux, you can run in your Windows machine, so you can run anywhere.
Awesome. Also, is there going to be a UI component created for Rosetta?
UI component, yeah, we already have a UI for Rosetta, but it's part of our commercial adaptive scale software. So with that software, people are able to do more stuff, create models interactively and so on. So for that, I can say just please join us on the upcoming webinar to see how these features and much more work in adaptive scale.
Awesome. Another one, how is it easier to create more tests for the models?
Tests, the ones that I demonstrated, right?
Yeah.
So our recommendation would be just go ahead, fork a copy of Rosetta from our GitHub, and you can check the test module where we have added the basic set of operators so far. But there is an opportunity to add more. If someone is interested to create a PR, we are more than happy to review it and integrate it in the next release of Rosetta.
Awesome. Another question to go off the comment you made before, how can we go about getting commercial support?
How we can go about getting commercial support? Yeah, that's something that, yeah, definitely we can arrange. We have a group of talented people and that do have lots of experience in supporting enterprise companies. So feel free to contact us and we are more than happy to help you with support or whatever need you have.
Awesome. And from another question from the demo, the connection had to specify table names.
Okay.
Is that necessary? What if there are like thousands of tables in the database?
Oh, no, actually that was not necessary. But since we wanted, we were playing and we didn't have enough time for today to show, but if you want, we want to show the use case where from a given database, you can extract only a set of tables, and for another database, you can extract everything. And we were specifying the list of tables just to go and identify which one we want to select. If you don't write the full list of tables there, we already had the database name at the top. It is going to extract everything for you. But that is not always the use case for various clients. So this is if you want to have just a subset of them.
Awesome. So optional field, if we leave it blank, it will extract the highest component, which is database level. Great.
Yeah, definitely.
Okay. I think that's all the questions we have. If you wanted to say anything else, Nuhi.
Thank you for the attention and thank you for the questions. I don't have to say anything else. I'm just looking forward for more comments, PRs, I don't know, whatever the community has.
Awesome. Thanks everyone for joining us today. I hope you have a great day.
Thank you, everyone, and we wish you a great day.